In this video, we will look at measures of center. This is a topic in section 3.1 of your statistics textbook. If you recall, in chapters 1 and 2, we looked at introduction to statistics, why we study statistics, some of the applications of statistics, some of the terminology we use in statistics. And then in chapter 2, we talked about charts and graphs, statistical charts and graphs. And these were all forms of descriptive statistics, where we're describing a data set. So measures of center in chapter 3 continues with that idea of describing a data set. We're generally given a set of data, and we want to look at ways to measure where the center or the middle of a data set is. So we will look at several measures. First off, we'll start with the mean. This is one that most of you are likely familiar with. It is simply the average. We add up all the numbers and divide by the total. Another common one is the median, the middle number in a data set, sometimes referred to as the 50th percentile. And the idea is half the data is below the median, half the data is above the median. The mode is generally useful more so with categorical data when we're counting something, so it's the most frequent answer, the most frequent response. We can also calculate it in a numerical data set. The mid-range is a quick and easy calculation. We simply take the average of the highest and lowest values in a data set, hence the term the middle of the range. Trim means and weighted means are sort of for specific situations. In a trim mean, we generally delete some values on the lower end and some values on the upper end and average what's left in the middle. This can help reduce the effect of outliers. Weighted means is when you have a case where not all the data sets are weighted equally. In other words, some data values are more important or worth more weight than others. So we'll start with this example. We have 12 numbers in this data set, so our n is 12. If we were to calculate the mean, we would simply add up all 12 of these numbers and divide by 12. So if you add 5.4 plus 4.3 plus 4.2, etc. Add all those numbers up and divide by 12, you get 4.4833. So there's the average or the mean. The median, when you calculate the median, remember you first need to put the data in order from lowest to highest, and you're looking for the value in the middle. Now if you have an even number of data points, there isn't one value that's in the middle, but it'll be the average of the two middle values. So in this case, the average between those two middle values is 4.4. And notice that if the median is 4.4, notice half the numbers are below that. There's 6 numbers below 4.4. There's also 6 numbers above 4.4, hence the median or the 50th percentile. In this case, there is a mode. Notice 4.2 is repeated. In a lot of numerical data sets, you don't have a mode. There may not be any numbers that are repeated. The mid-range is simply the average of the lowest and highest. So the smallest number in this data set is 1.9. The largest is 6.3, so the average of those is 4.41. Now, as we go through measures of center, we will look at them and compare them, because that is an indicator of symmetry in data. We'll talk more about this later in chapter 3. But symmetrical data sets, if you have a mean, a median, a mode, a mid-range, if all these measures of center are very similar to each other, that is a good indicator of symmetrical data. So in this case, we have very close values for measures of center. Now let's talk about trim means and weighted means a little bit. So suppose we have this data set here. So we have 10 numbers here. And if you look at these numbers, notice that the 99 is kind of out there a little bit. Most of all the numbers are in the 60s and 70s, and then that 99 is a bit of an outlier. So a trim mean is one way to sort of minimize the effect of outliers. And essentially what we do is we delete some of the lower values and some of the higher values. Now how many you delete depends on what type of trim mean you want. So for example, if I wanted a 10% trim mean, the idea is I will delete the lowest 10% of data values and the highest 10% of data values. So in this case, we have 10 data values, so 10% is one data value. So in this case, if I were to delete the lowest score, the 58, and the highest score, the 99, and then average the remaining 8 values, I would get a trim mean of 67.125. Weighted means, the idea of weighted means is that each data value carries a different weight. So grade point average or scores in a class are good examples of weights. In this case, the instructor weights the midterm and final much more heavily than homework and class attendance. So if this particular student had a 79 on the midterm and 82 on the final and 95 on the homework and 100 perfect attendance, what would their overall class average be? So we weight some values more than others. That's the idea of a weighted mean. So the basic formula is the same. We're going to add up our numbers and divide by a total. But when we add them up, we're multiplying by the weights. So I'm going to take each of those scores, the 79, the 82, the 95, and the 100, but I'm going to multiply by those weights, the 30%, 35%, etc. And then I divide by the total. Here I divide by the total weights. In this case, the weights are percentages, and notice they add up to 1, or 100%. So in this case, if I take 79 times 30%, or 0.3, 82 times 0.35, etc., I get an overall average of 86.15. Hence an weighted average. The midterm and final carried more weight than the homework and class attendance. Another good example of weighted scores or weighted averages is GPA. When you calculate your GPA at college, you have 4 points for an A, 3 points for a B, etc., but it's weighted by the credit hours of the class. So in other words, if you get an A in a 5-hour chemistry class, that will carry more weight than, say, an A in a 1-hour Ranger Connection class. So weighted average, it's still an average. We're adding up and dividing by a total, but the data values carry different weights.